Hello, my name is Kevin Smith. I'm a Keysight application engineer for oscilloscopes. In this video, I'm going to demonstrate a powerful new feature on Keysight's latest oscilloscope, the MXR. This is the Fault Hunter feature, and it is accessed from the Analyze menu. What I have here appears to be a nice, well-behaved clock. We'll use Fault Hunter to find out if that's really the case. What Fault Hunter will do is it will use one of two methods to try and characterize the waveform and look for certain anomalous features. I can do it by triggering, which will find rare faults but has certain limitations, or limit test, which is software based and will may miss rare faults but has fewer limits. I can run it for a minute, an hour, 8 hours, or 2 days. While I certainly won't torture you by running this for 8 hours or 2 days, I will torture you for a minute. Okay, so I'm going to click Auto Scale, and then once I click Auto Setup, that's when it'll start trying to characterize the waveform. So here it's going to collect some top and base measurements, do some pulse width measurements, rise time. And it's complete. Alright, so it has failed the positive glitch. If I click View, it has saved one of the glitches into memory, and I can bring it up right here. We certainly wouldn't want this going on our clock. I can also select Copy to Trigger, and we saw that it changed the trigger up here. And now I can directly trigger on this event. That's really a powerful feature. Now, what if I want to know how often this occurs? Well, I could hook up the trigger output to a second scope and try and make some measurements. Or, on the MXR, there is a built-in counter. Okay. Counter A and B can only work on edges, but counter C is a trigger qualified counter. What does that mean? That means that any trigger, any hardware-based trigger in this menu, glitches, pulse widths, patterns, runts, timeouts, windows, protocol, nth edge bursts, can be counted as either frequency, period, or totalize. So I'll just simply turn on frequency. Okay. And I can see very quickly that this trigger is occurring very reliably at about 3.5 hertz. I could even take this potentially out to 8 digits. It's excessive though. I could also, if it was not necessarily stable, I could click Totalize, and I could let it run over time. I can go away for the weekend, and go away for an hour and see how many events would occur. I can also use this with segmented memory and find out exactly when these occur. Going back to Fault Hunter, okay, I could try a different trigger. So here, I've selected the slow falling edge trigger. And so these are edges that are slower than most of the other edges, and we see that there's a lot of these. Okay. So you can easily understand how this is an extremely powerful tool. Please contact your local Keysight representative to arrange for your MXR demo today. Thank you.